Alrighty, so a horizontal point of inflection is a point of inflection that is also a stationary point. So if I'm going to start thinking about what this bad boy is going to look like, if it's a horizontal point of inflection and it's also a stationary point, it's going to look like that, or it's going to look like that. So next thing I know is that if it is a stationary point, that means that the first derivative is equal to 0, and it means that the second derivative is also equal to 0 if it is a point of inflection. So we're going to be using these two facts to solve for what k is. Okay, so first thing I'm going to do is I'm going to derive this expression. So if I want to find the derivative of this expression with respect to x, that means that I'm going to be deriving ln x over k. Now, it's important to note here that k is a constant value, meaning it's going to act like a number normally would. All right, so that's my initial statement. So now when I derive this first term in our expression will become 1 over k multiplied by the derivative of ln x, which is going to be 1 over x. So that's going to become 1 over kx. Okay, minus, now I'm going to take the derivative of this statement here. So it'll be k. Now I'm going to let u equal x. So u dash equals 1. And I'm going to let v equal x plus 1, v dash equal 1. Okay, so now I'm going to chuck it in the quotient rule to work out what is going in this section here. So on the bottom, it'll be x plus 1. That whole part gets squared. On the numerator of this expression, I'm going to have this part, x plus 1 multiplied by that part. So that's just going to stay like this. Subtractee, this one times that one, so subtract x. Now, when I simplify that, I'm going to end up with this minus k is equal to 1 over x plus 1 squared. Okay, and I'm going to let that equal to 0 so that we are going to be finding where we have a stationary point. So from here, I haven't tested this, but let's just have a little red hot crack. So I'm going to take this side over to the other side. So I'll end up with k over 1 x plus 1 squared is equal to 1 over kx. Now I can take this k over here and this x over here. So when I do that, that's going to give me, this k coming over here and dividing as well, will give me 1 over k squared on the denominator, and then this x will come across and multiply. So it'll be equal to x over x plus 1 squared. Okay, and now in order to get k on top, I'm going to flip my fraction. So k squared is equal to x plus 1 squared over x. Okay, so I've done about as much as I can do with this up until this point. Now, I could have stopped here and then derived the next part to see what would happen, which would have made a lot of sense. But, you know, here we are. Let's see what happens. All right, so now the next thing I'm going to do is I'm going to take the second derivative. So I want to do d squared of fx over deriving it with respect to x again. That's what that statement really means. So I'm going to be deriving this part here. So that was the answer from before, so that's the one we're going to be deriving now. Okay, so if I derive this first part of the statement, remember to make it derivable, that would be x to the power of -1, meaning its derivative will become negative x to the power of -2. Now, if I write that back in a fraction like that, it'll become -1 over x squared. So that first part of the expression is going to become 1 over kx squared like that, or -1, I should say. And now with this side part, now I'm ignoring the constant. I'm just going to take the derivative of this and then multiply it by the constant after, which is the same thing. So now instead of doing quotient rule again, I'm going to write it the way that I like to make it derivable. Now I'm going to apply the product rule. Oh, sorry, not product, chain rule. So the derivative of the inside is 1 multiplied by the derivative of the outside of this bracket will be -2, and this will decrease by the value of 1. And then I've got x plus 1 left in the bracket. So here that will be -2 bracket x plus 1 to the power of -3. Okay, and I left that whole thing equal to 0 so that I can get an expression for where the point of inflection is. So let's just start thinking about what we've got again. I've got this. This expression will become plus 2k all over x plus 1 to the power of 3. Okay, if I take this to the other side, it's going to make it positive. So 1 over kx squared is equal to 2k over x plus 1 cubed. Okay, so I've got that as my expression at the moment. Now, if I take this k up here, that's going to make it k squared. So now I've got 1 over x squared is equal to 2k squared over x plus 1 over 3. Now, the next thing I'm going to do is a tricky trick. I'm going to grab this from here. I found in the first one that k squared is equal to this. And so now I can substitute this back in as k squared. So this will become, as my statement, 2 times x plus 1 squared divided by x. And that's going to be divided by x plus 1 cubed over 1. Now remember, when I write it like that, that means that I can flip this fraction. So it will really become 2x plus 1 squared over x multiplying x plus 1 cubed, 1 over x squared. Okay, so because these two brackets are the same, that will cancel out with that. And now I could take this one over to the other side by multiplying, so that will times that, which will cancel out one lot from here and one lot from here. So instead of cramming all of this in, how about we scroll down so that you can see what I'm talking about. So I'm going to start over here. So after all the cancelling I just applied there, I'll end up with 1 over x on this side is equal to 2 over x plus 1 on that side. Now I can take, what do I want to take and where? How's about we take this to the other side. So that'll become x plus 1 on the numerator over x is equal to 2. Now, if I separate this fraction out, it will become x over x plus 1 over x is equal to 2. This cancels out to 1. So now I've got 1 plus 1 over x is equal to 2. So if I take this to the other side, it's going to subtract by 1. So now I have 1 over x is equal to 1. And then I take this up by multiplying. So therefore, x is equal to 1. Okay, so there was a lot of steps to get to that point. But we found out the x value for where we get that horizontal point of, or stationary point of inflection. To find k, all I have to do is throw this bad boy back into the expression that's k equals. So I can do that over here. So I'm going to substitute 1 in there, and then we'll see what happens. So k squared is equal to 1 plus 1 squared over 1 is going to be equal to 2 squared is 4, divided by 1 will still be 4, is equal to k squared. So then square root of that will be equal to 2. So if k is equal to 2, we're on to a winner.